Hi friends, I am Vijay Kumar. I am BSc BEd. Welcome to my channel Feed Knowledge. Please like, share, subscribe. Please click on bell icon. Click on to all. Today we are going to about the topic is 10th standard mathematics, real numbers, irrational numbers. The concept is irrational numbers. In class 9th, you are introduced to irrational numbers and may of their properties. You studied about their existence and how the rationals and irrationals together made up the real numbers. You even studies how to locate irrational on the number line. However, we did not prove that they were irrational in this section. We will prove that square root 2, square root 3, square root 5 and in general square root p is irrational where p is a prime. One of the theorems we use in our proof is the fundamental theorem of arithmetic. Recall, a number s is called irrational if we cannot be written in the form of p by q, where p and q are integers and q not equal to 0. Some examples of irrational numbers with which you are already familiar are examples of irrational numbers. Irrational numbers. Square root 2, square root 2, square root 3, square root 5, square root 5, 5, minus square root 2 by square root 3, 0.10, 110, 110, 111, 0, 1111, 0, infinity. Now, this is the concept of irrational numbers. Next topic is theorem. Theorem 1.3. Theorem 1.3. Let P be a prime number. Let P be a prime number if P divides a square, then P divides a where a is a positive integer. Let us see the question. Theorem 1.3. Let P be a prime number if P divides a square, then P divides a where a is a positive integer. Proof. Let the prime factorization of a be as follows. Let the prime factorization of a be as follows. A equal to P1, P2, up to Pn, where P1 comma P2 up to Pn. A equal to P1 comma P2 up to Pn, where P1 comma P2 up to Pn are primes, not necessarily distinct. A equal to P1 P2 up to Pn, where P1 comma P2 up to Pn are primes not necessarily distinct. Therefore A square equal to P1 P2 up to Pn into P1 P2 up to Pn. Now A square equal to P1 square P2 square up to Pn square. Now we are given that P divides A square. P divides A square. Therefore from the fundamental theorem of arithmetic, the fundamental theorem of arithmetic, it follows that P is one of the prime uniqueness, that P is one of the prime factors of A square. However, using the uniqueness, part of the fundamental theorem of arithmetic, fundamental theorem of arithmetic. Fundamental theorem of arithmetic. We realize that only prime factors of A square are P1 comma P2 up to Pn. P1 comma P2 up to Pn. So P is one of P1 comma P2 up to Pn. Now since A equal to P1 P2, A equal to P1 P2 up to Pn. Now since A equal to P1 P2 up to Pn, P divides A. P divides A. P divides A. We are now P divides A. This is the concluded. Let us see the problem. Theorem 1.3. Let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. Proof. Let the prime factorization of A be as follows. A equal to P1 P2 up to Pn, where P1 comma P2 up to Pn are primes not necessarily distinct. Therefore, A square equal to P1 P2 up to Pn into P1 P2 up to Pn. Now next step, A square equal to P1 into P1, P1 square, P2 into P2, P2 square, Pn into Pn, Pn square. Now we are given that P divides A square. Therefore, from the fundamental theorem of arithmetic, it follows that P is one of the prime factors of A square. However, using the uniqueness part of the fundamental theorem of arithmetic, we realize that only prime factors of A square are P1, P2 up to Pn. So P is one of P1 comma P2 up to Pn. Now since A equal to P1 P2 up to Pn, P divides A. Theorem is concluded. Next theorem. Theorem 1.4. Theorem 1.4. Square root 2 is irrational. Square root 2 is irrational. Proof. Let us assume to the contrary that square root 2 is rational. Square root 2 is rational. So we can find integers. We can find integers. So we can find integers r and s not equal to 0 bracket, such that square root 2 equal to r by s. Suppose r and s have suppose r and s have a common factor other than 1. Next step, then we divide by common factor 2, divide by common factor to get square root 2 equal to a by b, where a and b are co-prime. A and b are co-prime. So b square root 2. So b square root 2 b square root 2 equal to a. Squaring on both sides. Squaring on both sides. Squaring on both sides and rearranging, we get, and rearranging we get 2b square equal to a square. Therefore 2 divides a square. 2 divides a square. 2 divides a square. Now by theorem 1.3, it follows that 2 divides a. 2 divides a. So we can write a equal to 2c for some integer c. Substituting for a, we get 2b square equal to 4c square. 2b square equal to 4c square. That is b square equal to 2 square. B square equal to 2c square. This means that 2 divides b square. This means that 2 divides b square. 2 divides b square, and so 2 divides b. 2 divides b. Therefore A and B have at least 2 as a common factor. Have at least 2 as a common factor. 2 as a common factor. 2 as a common factor. But this contradicts but this contradicts the fact that A and B have no common factors other than 1. Have no common factors other than 1. This contradiction has arisen because of this contradiction has arisen because of four incorrect assumption. Four incorrect assumption that square root is rational. That square root is rational. So we can conclude that we conclude that square root is irrational. Let us see the problem. Theorem: square root is irrational. Proof: let us assume to the contrary that square root is rational. So we can find integers r and s not equal to 0 such that square root equal to r by s. Suppose r and s have a common factor other than 1. Then we divide by common factor to get square root 2 equal to a by b, where a and b are co-prime. So b square root 2 equal to a. Squaring on both sides and rearranging, we get 2b square equal to a square. Therefore 2 divides a square. Now by theorem 1.3 it follows that 2 divides a. So we can write a equal to 2c for some integer. Substituting for a, we get 2b square equal to 4c square. That is b square equal to 2c square. This means that 2 divides b square, and so 2 divides b. Therefore a and b have at least 2 as a common factor, but this contradiction contradicts the fact that a and b have no common factors other than 1. This contradiction has arisen because of 4 incorrect assumption that square root 2 is rational. So we conclude that square root is irrational. Sum is concluded.